Hi, this is Pavan Kamra. Today I would like to share summary of the book The Machine That Changed the World. This book provides an excellent overview on Toyota's lean methodology. This book was written as an output to the research done by few MIT researchers. This research started under umbrella of International Motor Vehicle Program IMVP, and it started during late 1980s. Researchers were impressed by their findings on Toyota production system and named it as lean production. Car production started in late 1880s as craft production. Henry Ford implemented his idea of manufacturing cars in plant during 1908 with Model T. By 1913, the plant was further improvised with assembly line. This brought an era of mass production. Around 1950s, Toyota started implementing its innovations in various aspects of car manufacturing. All these innovations were revolutionary and were later known as lean production. Let's look at each era of car manufacturing in a bit more detail. Before mass production started, cars were manufactured by skilled craftsmen. They used to hand build customized cars in small numbers. These workers understood mechanical design principles and the material with which they worked. Of course, these cars were expensive. This was about to change. Ford's 1908 Model T was his 20th design over a 5-year period that began with production of original Model A in 1903. With this Model T, Ford finally achieved two objectives. He had a car that was designed for manufacture and it was user-friendly as well. Almost anyone could drive the car without a chauffeur or mechanic. These two achievements laid the groundwork for revolutionary change in direction for the entire motor vehicle industry. Interchangeability, simplicity, and ease of attachment gave Ford tremendous advantage over his competition. Ford soon realized the problem with moving the worker from assembly stand. Walking, even if only for a yard or two, took time, and jam-ups frequently resulted as faster workers overtook the slower workers in front of them. Ford's stroke of genius in the spring of 1913 at his New Highland Park plant in Detroit was the introduction of moving assembly line, which brought the car past the stationary worker. This innovation cut the cycle time to half. Core employees or assemblers were unskilled, while there were a bunch of specialists. Workers on the lines were replaceable as parts of the car. Productivity improvements due to all these innovations caught the attention and sparked the imagination of other auto assemblers. Ford's innovations had cut the real cost to customers by 2/3. Henry Ford's mass production drove the auto industry for more than half a century and was eventually adopted in almost every industrial activity in North America and Europe. Moving on to Toyota. Toyota, a family founded company in 1937. They faced many Japanese domestic issues. They were thwarted by military government in their effort to build passenger cars in 1930s and had instead made trucks largely with craft method. At the end of 1949, a collapse in sales forced Toyota to terminate large part of workforce. Kichiro Toyoda resigned from the company for management failures. By 1950, Toyota could produce only 2,685 automobiles compared to 7,000 which Ford Detroit plant was manufacturing every single day. E.G. Toyota was not an average engineer either in ability or ambition. After carefully studying every inch of vast rogue plant, E.G. believed that there were a lot of opportunities to improve the production system. Back home in Nagoya, his production genius Taichi Ono concluded that mass production could never work in Japan. Domestic market at Japan demanded a wide range of vehicles, luxury cars for government officials, large trucks to carry goods to market, small trucks for Japan's small farmers, and small cars suitable for Japan's crowded cities and high energy prices. Compared to US, there were no low-wage workers available in Japan. There was strong influence of unions as well. There were new labor laws. Management's right to lay off employees was severely restricted. Meanwhile, Taichi Ono focused on minimal scale required for economic operations. The massive and expensive Western press lines were designed to operate at about 12 strokes per minute, 3 shifts a day. The dies could be changed so that the same press lines could make many parts, but doing so presented major difficulties. The dies weighed many tons each and needed alignment with absolute precision. Specialists were required for change in die and required a full day. This was a delicate process. Manufacturers used to dedicate presses to a specific part and stamp these parts for months without changing dies. To Ono, however, this was no solution at all. His capital budget dictated that practically the entire car be stamped for a few press lines. His idea was to develop a simple die change technique and to change dies frequently. He eventually reduced the time required to change a die from a day to astonishing 3 minutes and eliminated need for a specialist to do the same. Consequences for this discovery were enormous. Making small batches eliminated the carrying cost of the huge inventory of finished parts, and making a few parts before assembling them into a car caused stamping mistakes to show up almost instantly. Everyone in stamping shop became more concerned about quality, and it eliminated waste for a large number of defective parts. Ono needed extremely skilled and motivated workforce. Ono began to experiment. He grouped workers in teams with a team leader rather than a foreman. Team leaders would do assembly tasks as well as coordinate the team and in particular fill in for any absent worker. These concepts were unheard of in mass production plants. After the teams were running smoothly, Ono set time aside for the team to suggest ways to collectively improve the process. This continuous incremental process, Kaizen, in Japanese, took place in collaboration with industrial engineers who still existed but in small number. When it came to rework, Ono's thinking was truly inspired. He reasoned that mass production practice of passing on errors to keep the line running caused errors to multiply endlessly. Once a defective part was embedded in a complex vehicle, an enormous amount of rectification work might be needed to fix it. In striking contrast to mass production plant, where stopping the line was the responsibility of a senior line manager, Ono placed a code above every workstation and instructed workers to stop the whole assembly line immediately if a problem emerged that they could not fix. Ono went much further. In mass production plants, problems tended to be treated as random events. The idea was simply to repair each error and hope that it did not recur. Ono instead instituted a system of problem solving called 5 whys. Production workers were taught to trace systematically every error back to its ultimate cause by asking why as each layer of the problem was discovered. Then devise a fix so that it would never occur again. Not surprisingly, as Ono began to experiment with these ideas, his production line stopped all the time and the workers easily became discouraged. However, as the work teams gained experience, identifying and tracing problems to ultimate cause, the number of errors began to drop dramatically. Today in Toyota plants, where every worker can stop the line, yields approach 100%. That is, the line practically never stops. Even more striking was what happened at the end of the line. As Ono hit its stride, the amount of rework needed before the shipment fell continuously, and quality of cars steadily improved. Moving on to supply chain. Assembling the major components into a complete vehicle. The task of final assembly plants accounts only for around 15% or so of the manufacturing process. The bulk of the process involves engineering or fabricating more than 10,000 discrete parts and assembling these into perhaps 100 major components like engines, transmission, steering gears, suspension, etc. World's mass production assemblers ended up adopting formal integration. Ford actually approached 100% integration at its Rogue plant. Ono's approach was different. He explored how assemblers and suppliers could work smoothly together to reduce cost and improve quality, whatever legal relationship they might have. Toyota spun its in-house supply operations off into quasi-independent first-tier suppliers companies in which Toyota retained a fraction of equity and developed similar relationships with other suppliers who had been completely independent. As the process proceeded, Toyota's first-tier suppliers acquired much of the rest equity in each other. These suppliers were now intimately involved in Toyota's product development. Finally, Ono developed a new way to coordinate the flow of parts within the supply system on a day-to-day basis, the famous just-in-time system called Kanban at Toyota. As each container was used up, it was sent back to the previous step, and this became an automatic signal to make more parts. This simple idea was enormously difficult to implement in practice because it eliminated practically all inventories and meant that when one small part of the vast production system failed, the whole system came to a stop. All of the variety available from lean production would be for a naught if lean producers could not build what the customer wanted. Thus, from an early date, Eiji Toyoda and his marketing expert Shotaro Kamiya began to think about the link between production system and the consumer. Toyota built up a network of distributors, some wholly owned and some in which Toyota held a small equity stake. Gradually, Toyota stopped building cars in advance and worked only on pre-sold cars. Ono's production system was remarkably adept at building products to specific order. For Toyota production system, these developments were all blessings. Consumers began to report that most important feature of their car or truck was reliability. Japanese were able to keep models in production only for 4 years, as opposed to 10 years by Western counterparts. It took Eiji Toyoda and Ono more than 20 years of relentless effort to fully implement the full set of ideas, including just-in-time within the Toyota supply chain. In the end, they succeeded, with extraordinary consequences for productivity, product quality, and responsiveness to changing market demand. Toyota's model was now called Toyota Production System House, with JIT and Jidoka as two main pillars. Toyota had fully worked out principles of lean production by early 1960s. The other Japanese auto firms adopted most of them as well, although this took many years. By 1980s, leading practitioners attempted to increase their market share. Meanwhile, American, European, and even Korean firms, often accomplished masters of now obsolete mass production, tried to match or exceed the performance of their lean challengers. The Japanese companies also received a windfall from North American and European exports. IMVP set out to contrast lean production with mass production by carefully surveying world's motor vehicle assembly plants. They surveyed many plants across the globe as part of their research. The first set of comparison was between 3 plants. These 3 plants were, first one was General Motors plant at Framingham. It was selected because teams suspected that it embodied all the elements of classic mass production. Second one under their visit was Toyota Takaoka. Of course, it used lean production system. Third one was New United Manufacturing Inc. NUMMI. This was a transplant facility in US. In 1984, GM decided that it needed to learn about lean production from the master. So it convinced Toyota to provide the management for a reopened plant, which would produce small Toyota-designed passenger cars for US market. So what were the key findings? First one about GM plant at Framingham. There were a lot of indirect workers in the plant. There was a lot of inventory lying there. Work was unevenly distributed between the workers. There was a big rework area where there were a lot of finished cars riddled with defects. Large buffers of finished bodies waited their trip through the paint booth and from paint booth to the final assembly line, and massive stores of parts, many still in the railway cars in which they had been shipped from GM's component plant in Detroit. Workforce appeared to be dispirited. There was little hope that plant would last for the long. In contrast, scene at Toyota were different. There were large number of welding and painting robots. Hardly anyone was in the aisles. Practically every worker was actually adding value to the car. Every worker worked at about the same pace. Less than an hour's worth of inventory was next to each worker at Takaoka. When a worker found a defective part, he carefully tagged it and sent it to quality control area. Every worker could stop the line, but it was never stopped. There was no need. Morale of workforce was high. There was a sense of purposefulness. Toyota's leap in performance can be called a revolution. Moving on to NUMMI, 80% of the workforce consisted of workers formerly employed by GM at Fremont plant. NUMMI matched Takaoka's quality and nearly matched its productivity. Space utilization was not as efficient because of old GM plant's poor layout. Inventory was also high, as almost all parts were transported 5,000 miles. There was a stark difference in the statistics. You can see for assembly of car or defects, space per car, as well as inventory of part on an average. Takaoka was almost twice as productive and 3 times as accurate as Framingham in performing the same set of standard activities on our standard car. In terms of manufacturing space, it was 40% more efficient than its inventories. And inventories were tiny, a fraction of those at Framingham. By end of 1986, Toyota had truly achieved a revolution in manufacturing that old mass production plants could not compete, and lean production could be transplanted to any new environment like they did for NUMMI. Now what happens inside a lean plant? There are workers, so responsibility to complete the task goes to workers, and they are actually adding value to the car on the line. In the plant, we can see some end-on boards which are displaying targets, daily production targets, car produced so far, and other statistics. They are visible from every workstation. In the end, it's the dynamic work team that emerges at the heart of lean factory. Building these teams takes time. First, workers need to be taught a wide variety of skills. Then they need encouragement to think actively, indeed proactively, so they can devise solutions before problem becomes serious. Workers respond only when there exists some sense of reciprocal obligation, a sense that management actually values skilled workers. There have been some critiques as well. The questions have been that lean production is even worse for the workers than mass production. There's more stress as we identify and remove unused work time, excess workers and excess inventories. IMVP team agreed that properly organized lean production system removes the slack, but it provides workers with the skills they need to control the work environment. Lean production offers a creative tension in which workers have many ways to address the challenge. To make system work, management must offer full support to factory workers, but at the end, workers become highly skilled problem solvers. There was another critique in Europe. There was a lot of trend of neo-craftsmanship, where small teams built the cars, but the team did not agree. Researchers thought it takes us back to the era of handcrafting. Another key point was that in lean there's no safety net. Yeah, researchers agreed that for lean model to work, it's essential that every worker tries very hard. People's initiative and responsibility to continually improve the system is key to the success of lean. At the end, study convinced the writers of the book that principle of lean production can be applied equally in all industries across the globe, and that the conversion to lean production will have a profound effect on human society. It will truly change the world. Thank you so much for listening. Have a great day. Bye-bye.